What's up, my people? Learning Target 1 Algebra. We got four of them in this chapter. That's how important algebra is going to be. It's going to come up again and again and again. So I hope you like Algebra Mondays, because I'm going to have 4 different videos for you and a few different examples. So first one here, the square root of 75. I don't know anything off the top of my head that multiplies to equal 75. That's the same number. That's of course because our perfect squares, you know, we have 9 squared is 81, 8 squared is 64, and it's somewhere in the middle. Well, yeah, if you ask Siri what the square root of 75 is, she gives you this crazy gibberish decimal that keeps going forever and ever. So, as mathematicians, we want to be as precise as possible. So, if you don't recall, when you have something like the square root of 75, we go fishing for the biggest perfect square fish that we can find to pull out to simplify a square root, simplify a radical. So the square root of 75, yeah, no, we're not going to do that. Instead, we're going to simplify this and say the square root of 25 times the square root of 3 is the same thing as 75, this being the perfect square, biggest perfect square that I can fish out of that 75. And then the square root of 25 is 5, so we get 5 root 3. It's kind of like imagining, all right, the perfect square is 25, but when you pull the 25 out of the square root, then it would turn into the normal 5. You'd have the root 3 left over. All right. Example 2 takes that to another level. You're doing a regular number divided by an irrational square root of 2. So yeah, that's like 5 divided by this gibberish decimal that keeps going forever and ever. And how do you divide by a decimal when it keeps going forever and ever? Let me know if you figure that out. Yeah, no, so instead, there's this rule that says, thou shalt not ever leaveth a square root in the bottom of a fraction. So it's called rationalizing a fraction, because you cannot have a square root on the bottom, like we said. Now there's kind of like a hack here. So we know that square root of 2 is irrational, but if we actually multiply any square root by itself, it turns into the normal number. Let me just do an aside here. So like, think about this for a second. What's the square root of 9? 3. What's the square root of 9? 3. So 3 times 3, oh, so 9. So then up here, root 9 times root 9 is just 9, right? Any square root times itself just gives you the number underneath. Or we could almost think of it as root 9 times root 9, or root 9 squared. And the square root and the squares would cancel out and you'd have just the 9 left over, okay? So we kind of use this idea here for this 5 root 2. And what we do is we take our 5 root over root 2, and what we do is we multiply it by another root 2. So then this would then turn into a regular 2. But of course, you remember back to like 4th grade, is when you take a fraction and you multiply either the top or the bottom, the numerator or denominator. When you multiply it, you also have to multiply the top by the same thing. So the difference here is 5 times root 2, not square root world, yes square root world. So when I multiply those, I can't actually do anything. So then this is considered a more rational answer because I'm just dividing by 2. I'm cutting it in half. We know how to do that, right? How to cut something in half, right? So, you know, I could technically say I could do half of 5 is 2.5 root 2. It's just we don't use decimals, and that just makes it more complicated because you have this crazy decimal and another decimal and you're multiplying them. So instead, this is considered rationalizing the denominator, coming from 5 divided by root 2 making it not divided by a root by multiplying by itself, turning into a regular 2, but then I also have to multiply the top by root 2, okay? So simplifying a radical, rationalizing the denominator, both epically important. So make sure you practice those you tries in the notes, all right? Peace.